Okay, so we have our next speaker, Tomas Herceg. Hi, Tomas.
Hello. Greetings from the Czech Republic.
Tomas will talk to us today about microservices, and to begin with, I would like to ask you to say a couple of words about yourself, what you do and where you work.
Okay, my name is Tomas Herceg. I'm Microsoft MVP. I live in Prague, Czech Republic, and I'm running a small software company called RIGANTI. And for the last couple of years, I have been working mostly with ASP.NET Core and microservices, software architecture, design patterns, and all those topics related to that. So that's what I do.
So you probably build your applications based on the microservices architecture, given the fact that you are talking about this on the presentation, right?
Yeah. Oh, yes and no, because we have been building a lot of applications. Some are using microservices, some are more monoliths, and we have been also helping a lot of other companies to run and build their microservices projects and set up all the infrastructure around that. And so we have assisted also other companies with microservices projects. And it's kind of fun. Also, some monolithic projects can become microservices projects over time. So it's very interesting. And every microservices application is very different from the other ones.
Отлично, какой у тебя разносторонний опыт. Как ты думаешь, микросервисы уже стали стандартом?
Great, so you have wide experience. Do you think microservices are already a standard for the industry, or the monoliths have its niche and application?
I think there are room for both, because if the application is small enough, then monolithic solution is just okay. There is no need to complicate the things with complex deployments or Kubernetes and things like that. If it's small enough, if there is one small team working on the application, then it's great, and there's no need to make things more difficult. However, if you have multiple teams, or if you really need to compose the solution from multiple different pieces with different and standalone deployment model, release management, testing, and things like that, then microservices makes sense. So I think that, and yeah, it's becoming the new standard, but there are some waves, because a few years ago, there was always monoliths with crazy complicated databases. Some years back from there was also some tendencies to not that it wasn't called microservices, but more like service-oriented architecture. But in principle, it's very similar. So I think that maybe it's just a pendulum that goes from one way to another and then back. So let's see. But yeah, right now microservices are very popular.
So you think that in a number of years we will see a massive move for the projects from microservices to monolith, right?
Maybe. I don't know. Nobody knows. And also I think that really there is a wide variety of projects. So maybe microservices will become more popular or less popular. Maybe there will be some new approach, or just a new name for some older approach. It depends. I don't know.
Okay, so we can talk microservices for ages. I welcome Tomas to talk about his experiment and his project. So you have the floor, Tomas.
Okay, thank you. So I will be talking about Project I. It's an experimental project developed by people from the .NET team, and it's a tool that helps .NET Core developers to have their life easier if they build microservices projects. So if your application on .NET Core is composed of multiple components that are independent, maybe they can communicate with each other, but they are separate processes, separate applications, and you build them as a one solution, then TIE can be very interesting to you. So I will talk about what TIE is, how it can help you, and you will see some demos. So how many times have you heard this sentence, oh, wait, let's use microservices for the next project we have in the company? So it's become really popular, the microservices having the traction right now. And instead of what this means, that instead of building one monolithic applications, you end with several apps that live on their own. They can be on different servers. They have different performance characteristics, performance requirements. There are also new types of applications. For example, the serverless things like Azure Functions. Yeah, it doesn't need to run on a physical server. It can be somewhere in the cloud. You don't even need to care about how many servers it will need, how much memory did it use. Yeah, because that's the cloud who takes care of it. And also there are quite a renaissance of different ways of communicating between these components. It's not only REST APIs, it can be some kinds of messaging or event sourcing or other ways of exchanging data or persisting data in the solution. And every service can have its own data store, or there is one big database that's separated to schemas or something like that. So it gets quite complicated. And there is the fundamental difference between taking care of one application, because it's very simple, and between working with 10 independent applications that needs to run, that needs to see to each other, and that are working with some shared data, for example. So now I would like to talk mostly about the developer experience. When this complicated thing goes to the production, it brings a lot of other challenges. But right now I would like to talk about the challenges you will face as a developer when you are just writing code, when you are building the application, because you will need to run all the services or most of the services at the same time. You make a change in the code and you want to run everything and make sure it's working. You will need to configure the communication ports or anything else to make sure that the components can talk to each other. And maybe you will need some external things like a database. You can use, for example, MongoDB or any other popular document databases, which are also very frequently used in microservices solutions. And you don't want to install it on your very machine, so you can run it as a container or something like that. But it's an integral part of the application. You need to have it running. And maybe you will need to reset the state or try to experiment, so it's easier to run it in the containers. Now you have a lot of components, so you will probably have a lot of log outputs. There is no single log file where you can find everything, but you will have many different log files, and you will need to make sure or determine which entry belongs to which, because if you do one thing in the application, it can go through a lot of services, so some artifacts will appear in multiple log files. So you need to be able to find which is related to which entry in the another file. And finally, you will need to deploy the thing. And again, I'm not talking about the production environment, but even if you want to deploy it to some test environment to pass it to the testers so they can make sure it's working, it's also not trivial. So TIE is the tool which can help you with all these challenges. So if you want to run it all at once, there are multiple things you can do right now without TIE. There is a feature in the Visual Studio that will allow you to run multiple projects at the same time. So if you hit F5, it will run more projects in your solution. it can bind debugger, and it kind of works. However, if you want to run another thing like a container alongside with the solution, it's not possible to do it easily. You would need to write some scripts or something like that. Or there is another way. If you have already containerized your application, if you created Docker containers for all the components, then you can create Docker Compose script, which will take care of it. It can run everything at once, and it can be pretty convenient. However, it's a little bit slow because for every change in the code, you need to rebuild the containers. And there are some things, so not everything is rebuilt from scratch, but still it needs to copy the files to the container. And if the solution is large, then you will wait maybe for a minute before it runs. So there can be something that could make this experience more happy. The other problem is configuration and something like service discovery, because if the services need to talk to each other, they need to know the URL or the port or something. They need to know where they should send the messages. And if you are building the solution on your own, and you don't have a team, you are just you, and you are working on your machine, it's easy because you can hard code the ports and everything will run on localhost and some port. But if you need to work in a team, that means that you maybe will need something more clever, because the ports that are working on your machine may be used on your colleague's machine by some other application, or he can also work on other projects, so there can be conflicts in the port numbers. And if they are not hard coded, it means that you will need to have some configuration in every application, so you will be able to tell where the service is running. If you are using Docker Compose, it's a little bit easier because the ports can be hard coded. They are not the ports on your machine, there are the ports in the container, so every service can run on port 80, and there will be no conflicts because every service, every container will have its own network interface. And then there is the integrated DNS, so you don't need to use localhost, you can use the service name and the static port. It's a little bit easier, but still there can be problems. Some services can block some of the ports because at the end of the story you will need to connect to some of the containers, for example, to run your front end or something like that. So you will need to tunnel the port from the container to your local host. And again, there can be conflicts, and this is not easy to solve sometimes. The next thing is logging, because, as I said, every component produces its own logs, and you will need to have some way to be able to tell, okay, this event in log 1 belongs to or is related to this event in log 2. So you will need to have some concept of correlation ID or something like that. So when the first service gets the request from the user, it should assign some kind of ID and send it to the entire communication with other services. So you will be able to search by this correlation ID in the log files. And again, it's a thing that you, of course, can build yourself, or you can find some solution, but it's one of the challenges you need to solve. Otherwise, it would be very difficult to debug anything, because you need to know some footprint of which event caused this log entry. And it's simple if you are looking at one log file, because the entries are sequential, so you can see what happened at each time. But if it's spawned in multiple files, then it's a problem. You can, of course, use some cloud service like Application Insights or something like that, but it's not very practical for development scenarios, because your logs may be mixed with your colleagues' logs. Otherwise, you will need to have a separate account for every developer, which also you need to have some configuration that's not stored in the Git or something like that. So it can be done, but it's not ideal, it's not easy to set up, and therefore we may be looking for some easier solution. The next thing is monitoring. If you run everything, you need some maybe simple dashboard that is able to tell you, okay, all the services are running. There are no startup issues, maybe some health check and things like that. For example, if you are running in Visual Studio or in Docker Compose, there is not an easy way to display on one click if everything is running. The new version of Docker, it has some kind of dashboard, so it's easier, but still it depends on how you have the workflow set up. If you are using multiple startup projects in Visual Studio, basically there is no way to tell if everything is running. You would need to build something on your own or use some existing dashboard. And the final thing is deployment to some test environment. You have your 15 applications and you need to deploy them. And today you want to do things like continuous integration, continuous delivery, so it's possible to set up a pipeline, but where do you want to host it? You want to host it on some Linux machine using just Docker Compose, or you want to try it in Kubernetes because there is a chance that in production it will probably also run in Kubernetes, so you maybe want the test environment to be as close to the production as possible, so you will need to deploy this to Kubernetes. And they need their YAML files which describe all the services or the deployments and things like that, some ingresses maybe, and you need to build these files or create them. You can use tools like Helm that will help you to generate this stuff, but still it's a lot of things to learn, and if you are starting, if you have never used Kubernetes before, it can be really overwhelming. So that's also a thing that Ty can help you with, because for test deployment, it's good enough. It can generate those things for you. So let's start with the Ty. It's, as I said, it's an experimental project that is built by a few people from the .NET team. It's developed on GitHub, and the community there is very active. I've been submitting a few issues, and I get the response in a few hours, so it was very quick. I had some problems with making the demo running, and they helped me. It was amazing. I was really thrilled by this, and the project is still in development. It's a still experimental one. The current version is 0.4, so I wouldn't say it's a production ready, but it depends, because it's a development tool. It's not running in the production. It's a tool that can help you with. So there are some risks involved if you want to use Ty right now, but since it's not a code that is actually running in your production, it's not so risky. So you can try it and you will see if the tool can help you. Basically, it's a thing that can run all your services in the solution at the same time. There is a dashboard that will tell you, okay, everything is running. There is quite an easy way to see the logs of each service. So still there's a lot of log files you need to discover, but it's on. You can display the log file on one click, so it's very easy and very convenient. It can create and push Docker containers for you. It can deploy the application to the test environment in Kubernetes. And the most important thing is the service discovery. Basically, it runs the services on randomly generated ports, so there won't be any conflict with other things in your system. And it supplies the configuration to all services in the solution. So the ports are not hard-coded anywhere, but all services will know where the other services is running, because Ty supplies environment variables to all the services, and it tells where each other service is running. So it's done for you, and there is just one extension method, Get Service Uri, which you need to use in your application, and you will get the real URL of the service. So it's very convenient and practically zero configuration. You don't need to take care of some app settings JSON files in each service, and whenever you need to change the port, you will need to probably do search and replace in the entire project, because there will be many places where this port would be set up. So Ties make this zero configuration. It will bind the services together automatically. So if you want to try it, it's very easy. You can just install it as a .NET tool. So you can run .NET tool install Microsoft TIE, use the -G, so it will install it globally. And because it's still not a stable version, it's 0.4, you need to include this version 0.4. I recommend you to go to GitHub and look at the documentation, because there is the current version. This is the current at the time when I'm speaking, but if you will try it in a week, probably there will be a newer version, so you can try it. And what this does is it installs a global tool called TIE, so then you can use TIE build, TIE run, and other commands. I will be showing them in a minute. So let's look at the demo. Okay, I have a simple application, and it's really a demo. It's basically a hello world, nothing really complicated here. And it consists of two parts, backend and frontend. Both are ASP.NET Core apps. TIE works just with ASP.NET Core. It's a .NET Core tool, so if you are using other technologies for building your microservices, TIE will probably not be very useful for you, but who knows, maybe. Now I have the backend stuff. So it's a very simple API. There is just one API which gives me a weather forecast, and basically when it gets a request, so it generates some random weather. So it's not very accurate, but I haven't seen a better weather forecast. That's the API. That's very simple. And here I have an application. It's basically when the page is loading, it will download the weather using just REST API. So it's a REST API, so it will do a HTTP request using HTTP client, and it will parse the response as a JSON to some objects. So that's it. And I have a command line some here, and now I am in the directory where I have the solution. So src, and here is my solution file. Here is my backend and frontend project. And if I run TIE run, then it auto discovers all the projects in the solution that can be run, and it will run them. So it's very easy. You don't need to do any configuration. Just install the TIE tool. Before I will do this, I will show you one thing I have already mentioned. If you go to the solution and expand properties, then there is an option to say multiple startup projects. So if you are not using TIE, you can still run multiple projects in your solution. You can here specify if you want to start with debugging or without debugging, and that's what you can do. But the ports, every application will run on localhost :something, and you need to have a configuration. So you need to have the URL of the other service in your configuration file. And if you commit this in your Git and your colleague will download this, the problem is that this file, log settings.json, is typically ignored in Git. And this is the file where you can see these ports. So probably when your colleague runs it, he will have different ports. So that's a problem, and you will need to put this file in the Git if you want to use multiple startup projects. If you don't want to use it, we can adjust the project so it will support TIE. So instead of reading the value from my JSON file, from app settings.json, I can just use this. There is an extension method called configuration Get Service Uri, and it comes from this NuGet package, Microsoft TIE extensions configuration. So if you install this NuGet package, I can see some artifacts on the screen. Hopefully it will get better. Okay, so if you run and install this package, you will get this Get Service Uri, and you can just say project name backend, and it will give you the URL where the backend service is running. Basically, the TIE will run these processes with environment variables. So there will be environment variable, something like service underscore backend underscore URL or something like that. And this extension method will find this configuration entry and it will just use it. So that's how I can get the URL of the backend service. So now my code is updated, so I can actually use TIE run, and it will discover the projects in the solution, and it will run a dashboard for me. So here is a URL, and if I put it in my browser, then I will, sorry, I need to use the other window. Okay. Okay. Okay, so this is the TIE dashboard, and you can see what services are running in your project. You have the bindings, and these ports are randomly assigned, so this port is different than that I have been using when I run this from the Visual Studio. You can browse logs of both services, so it's very easy to display log of each service. You can see that it's running in one replica, and there were no problems because it doesn't restart it. When there is an exception and the service crashes, TIE will automatically try to restart it. So if you see that this number is rising, then it means there is some problem. You can look at the logs and you will see probably what's wrong. So if I go to the front end, I should see the weather forecast, because the front end service get an environment variable with the correct configuration for the backend service. So it should run. I don't know what's happening. Okay, yeah, it just took first request is always a little bit slower because the app is compiling, but it looks like it's working. This front-end service just rendered HTML table based on the data it got from the REST API. To make sure that the REST API is running, when I open it, I get 404, which is correct because the API is running on weather forecast. So you can see the JSON coming out from the weather forecast API, and it's basically a random. You can see it changes when I refresh the page. Yeah, but this URL is passed to the front-end service using environment variable, and TIE does this automatically, so you don't need to have the configuration of ports and URLs of other services. When you deploy this to Kubernetes, the URLs will look differently, but TIE will make sure that the environment variables passed to the containers will be correct. So no matter where it's running, the service discovery should work. So this is the TIE dashboard. And I didn't have to configure TIE at all. I just run it in the directory where my solution file is present. So it auto-discovered the solution and find all the projects that could be run. And that's how it do the stuff. There is a way to configure TIE. When I close it, I can say TIE init, and it will create a configuration file for TIE, and it will discover what's there. So I can open the file. Okay, I want to see it in Visual Studio, so let's run VS Code, and hopefully I will see the file. And it's a YAML file which describes all the services in the solution. And you can add another things here. So if you want to pass some extra environment variables, or if you want to include some other components like a container with the database, that's how you do it. You can write TIE init, have the configuration file being generated, and then you can modify this configuration. And when you run the TIE run and the TIE YAML is present, it will be used. So that's how you can configure TIE if you want to, if you have some extra setup. So that's how it works. As I said, if you just run it in your solution directory, it will auto-discover the projects you have in the solution, and if it's runnable, it will run it. If you have TIE YAML there, you can specify more things. You can do, for example, the most frequent things you will probably do is the additional containers. So if you want to include some database or some messaging within your application, you can add another services and say, okay, this service is a container from this image, and you can map some volumes and pass some other environment variables, anything like that. And TIE will run it alongside with your projects. Also, you can specify ingress. Most microservices applications have something which is called API gateway. Basically, there is one central place where all the requests go, and based on the URL patterns, they get redirected to individual microservices inside. So that's what you can use in a TIE YAML. It's called ingress because when you deploy it to Kubernetes, that's also named ingress. And basically, TIE will run a special proxy in front of your containers, and it will make sure that the ingress rules will be enforced. So if you put a request to /API/something, then it will go to your API service. If there is no API at the beginning, it will go to the front-end service to serve your, for example, React scripts or HTML files or whatever. Yeah, so that's what you can do in the TIE YAML. And when you deploy it to Kubernetes, it will translate and it will generate the Kubernetes ingress, and it should work the same way as on a local machine. So that's pretty convenient, because if you if you want to use ingress in your developer scenario, it's not easy to set up. You will need to use Nginx or some other web server and configure it. TIE will give this to you for free, so it's very easy to use. And the service discovery, as I mentioned, it works like that. It's, as I said, TIE sets environment variables to all the components, and the format is this. So the environment variable is called service, name of the service, and there is protocol, host, and port. So, for example, HTTPS localhost 12345. Or some services don't have this scheme. They can have some complex connection strings. So there is also connection strings and the name of the service again, or name of the connection string. And the TIE package, the Microsoft extensions configuration TIE, they have these extension methods which you can use to read these variables. So you don't need to look in the process environment variables. You can just use these extension methods, and you will just pass the name of the service, and you will get the result you need. So it's very, very useful. And if you want to run the containers within the application, so it's easy. You can just register this in a TIE YAML. So let's see how it works. I have a more complicated project. It's also not very difficult. It's not very large microservices solution, but it has 32 projects. Most of them are some class libraries, and they are a little small. So in reality, there is about 10 servers needs to be run. All those projects with the blue icon, they are web apps, either APIs or real web applications. And all this needs to be run in order to make the application working. And because I want to use MongoDB with my application, and I don't have MongoDB installed on my machine, it's very easy to just include it in the TIE YAML. So if I again run VS Code, so you can see my TIE YAML, and so here are the services. I want to pass some specific environment variables like ASP.NET Core environment development. So I have added this to all the services in my solution, and you can see there's a lot of them. And at the end of the file, I have two containers. So this is what I added to my file, and there is the name of the service, which is called Zipkin. Image is this, and it has some bindings, so there is some protocol and port, and also the MongoDB, and using the Mongo latest image and the binding, and now I specify a connection string, so that's this connection string. And because MongoDB needs to store data somewhere, I also can specify volume, so the data are persistent. Yeah, so because when you get rid of the container, you will lose all the changes it made to its own file system. But if you use volume, so you can map some external directory into the container. So what I'm doing is that I said that the /data/db in the container will be mapped to some folder on my machine, which is called Mongo Data. It's a named container in Docker. So that's why when I run it again, I won't lose the data. I will have the data with me. And of course, I can wipe the directory, so it's very easy. If you made a mistake in the database, you can just wipe it out and have it generated from scratch, for example, if you have some scripts to do this. So when I run tyrun, it will read this YAML, and it will run all my projects and those two containers. So let's do this. Tyrun. Now it will take a little bit longer because there is more projects to be run, but hopefully it won't be so long. And I can again run the dashboard in the meantime. Normally it's faster. That's because my machine is also grabbing video of the screen for the live presenting. That's what slows it down a little bit. So normally it is faster, but since now I'm live presenting, it's still building the projects and preparing the Docker images. So it shouldn't take a lot longer. When I'm not presenting, it takes about 10 seconds or something like that, which is still good for a project that has 10 runnable components and 32 projects. And that's also because of .NET Core, because it's also quite fast, especially if you are upgrading to the latest versions. Every version is faster than the previous one, so it's very nice. Okay, so now it seems to be starting. It starts all the containers. Now it stopped producing some output, so hopefully I can get to the Thai dashboard, and you can see there is replicas 1 of 1. So that means it really works. All the components should be running. And at the bottom, I have the two last one. The first is Zipkin, which I will talk in a minute about, and the second is Mongo. So if you want to, I can display the logs, and you can see all those environment variables that have been passed to the container. So even the containers will know about the other services. And yeah, so if the database would like to communicate with the admin website, which is improbable because it shouldn't, but still, if it wants, it has the protocol and port and the host. Yeah, so the variables are passed everywhere, and I can run my admin app. And I'm not sure if I would have to sign in or if I have the cookie from the previous time. Let's see. It takes also, the first request takes a little bit longer, but I suspect that this is because of the recording. Normally, it's not so slow. Yeah, so I can see the dashboard. By the way, this is the registration site I'm using for one conference in the Czech Republic, which I happen to be the organizer of. So we have a list of events we have been doing. We have a list of orders, some discount codes, emailing for the newsletters and things like that. So basically, this is the dashboard, which shows how many tickets we have sold. Of course, this is the fake data. I've just made several orders before the conference. So that's what we have here. And I have mentioned the Zipkin. It's a useful tool which will help you to orient in your log files, because TIE just allows you to see the logs of individual services, but it doesn't do any wiring up the events which belong to each other. So that's what Zipkin can do. And because it's just a container, it's very easy to add in my solution. So basically, it's not a feature of TIE, it's a feature of Zipkin, but it's pretty amazing, because what Zipkin can do, it's basically a monitoring application. And if your services will send information about HTTP requests they are doing to Zipkin, then you will have this dashboard. And if I run the query, I will see all the requests from my applications, and they are grouped together. So if I, for example, refresh the admin portal several times and go back to Zipkin, you will see I got a few requests here. And when I click on the request, and it's a request to the admin app on the root URL, you will see that this admin app made a request to the events service, and second request to the event service, and also a request to the order service. And all the requests got status code 200, which means it's okay. But if there is a problem, I'm able to dig into the individual requests, see the dependent requests, which were created on behalf of this first request, and I can probably see what's wrong. So this is quite a useful tool. It can also visualize your dependencies. So you can see that there is the admin app, which is talking to the events app and orders app. And these are just microservices. This is the front-end side I have been showing. So this is a very useful developer tool. And the only thing you need to make it running is to add a few lines in the startup file. I'm using packages which are called Open Telemetry, which is a great open source project, which basically it intercepts the incoming and outgoing HTTP requests from the application. So it binds to HTTP client, it binds to a SPNet Core pipeline, and it can supply the tracing ID. So when it gets the request and there is no special header with the tracing ID, it will generate some tracing ID, and it will pass the tracing ID as a header to all the subsequent HTTP requests the application was creating. So that's how Zipkin can then use this tracing ID to pair which requests belong to each other. And also there is a extension for Zipkin. So if I'm using Zipkin, I also call this extension method and say, okay, send all those traces to the URL of the Zipkin. Yeah, which I'm also doing get service URL Zipkin and / and this is the what's after the URL. So all my services are now catching all their HTTP traffic they are doing and sending the information to Zipkin, and Zipkin can show me this dashboard. So it's a very useful tool, and it's very easy to set up because you just add Open Telemetry with the Zipkin extension. And the package which contains this magic is called Open Telemetry, and you need Open Telemetry Collector ASP.NET Core, Open Telemetry Hosting, and Open Telemetry Exporter Zipkin. Yeah, so this is what you can use, and it's very nice because you just add some NuGet packages and few lines in the startup, and you get all your HTTP calls instrumented, and you can visualize that in Zipkin. And it's just one Docker container you need to run together with your application to see this data. So it's very easy to set up. You don't need to, it takes 5 minutes basically to set up. So it's very convenient, very productive. Okay, so that's what I had prepared. I haven't shown a lot of features of TIE. One of the new things that has been added to the TIE was an integration with Azure Functions. So if you have some projects that are Azure Functions, you can make Thai work with them. And also, I haven't been showing the deployment to Kubernetes, but basically it's pretty easy. You can just write Thai deploy, file a few secrets, and the application will get deployed to your Kubernetes cluster, which you are bound to. So that's you can find more information on the GitHub site of Thai, and there is also a step-by-step tutorial how to deploy with Thai. So that's it. And if you have any questions, I'd be happy to answer them.